This is a more complex music program I wrote. There's a simple one out there I've got a video on. This is more complex because this allows each note to have an octave, a note, and then a duration. So yeah, the other one had a single duration for all the notes. It was the same duration for all notes, and it only had one octave, although it did have regular notes and sharps. Okay, so this one is quite a step up. Let's take a look at it. First of all, we're going to import wind sound. X will be the note and Y will be the octave. So down this column we have the octave. This is the Y, so from 0 to 8, 0 to 8. And then across this way, X, we have the note. Now normally what you'll see in music is you'll see C, D, E, F, G, A, B. Okay, well, to make the array work more nicely, I've moved the A, B over here so it'll go 0, 1, 2, 3, 4, 5, 6, so I can access it this way in a more normal fashion. But it's not going to change things. It's just a compromise to make the program work a little nicer. Okay, so this is our regular note array. All of these numbers represent the hertz, the frequency in hertz of each of the given notes. Regular notes, and then down here are the sharps. Again, we've compromised by putting the A and B's up front. The 0 column is where there's no sharp or flat. There's just a placeholder. So again, it's a concession to the fact that I don't want to have. I got to have something in this array, but I don't want to try to do weird stuff in the processing. I just left a placeholder in there, and of course I won't access that. These are more comments. So this starts out by telling the user this is a music program, it's more complex, it'll handle octaves 2 through 8. Middle C is 4C, it's 440 Hertz. So the user can enter the octave, the note, and the note duration in a triplet, like octave, note, and duration, separated by spaces. So an example would be 4C2, 4C3, 5C2, and each separated by spaces. Capital letters represent a sharp. This is just a list of do, re, mi, fa, sol, la, ti, do, and C, D, E, F, G, A, B. And here are some music samples that the user can copy and paste into the input so that they do not have to retype it every time. So let's look at the program. The program's not too ferocious. It's just this part right in here. This is the variable that's going to accept the input from the users, and this of course is the message saying input notes to play. So we're going to loop through the input. So for note in music in, and we're going to split on spaces as I said earlier. So this is music in, this is music in, and note is going to go through here. We're going to strip out each of the note triplets, if you will, for each of the notes, and we're going to print what the notes are. You can see over here where I've run it before. This is what the note triplet looks like, 4C2, something like that. Okay, so we're going to default the frequency to 37, which is, I call it silence. It's not truly silence. It's a very low frequency. It's hard to hear, but yeah, wind sound doesn't like true silence. So this is the default for the frequency. And then we're going to get the octave, and we're going to set the octave, which is the first character down here. In this example over here, it's 4. So we're going to set that, and we're going to grab that from note 0, which is that first of our triplet. Okay, if the second value in note is capital A, B, C, D, E, F, or G, these are the sharps. We're going to deal with the sharps. So that's the second letter over here. We don't have any sharps in this list, but those are the sharps, and if it's there, then we're going to take X of int of ord of note of 1. So a capital A is the ord of that, the ASCII value of that is 65. So I'm going to subtract 65, and that will allow me to go from 0 to, so this will be 0, 1, 2, 3, 4, 5, 6. So it'll allow me to go from 0 to 6, so I can access the array back up here. And this will be 0, 1, 2, 3, 4, 5, 6, like that. So that's why we're doing that. So we'll get that X value. This is a debug statement I left in there. And then we'll get the frequency which is sharp octave of X. So we're going to set the sharp frequency, and then if it's not a sharp, we're going to fall through here to else if note of 1 is in small a, b, c. And so it works pretty much the same, except that a small a is value 97, so we're going to subtract 97 so that we can go from 0, 1, 2, 3, 4, 5, 6. Same as the other, but in that different array, but in the regular note array. Same thing. Okay, so down here, same thing for frequency. We're going to grab the frequency from the list, and then if this condition aren't true, then we're going to set x equals 1, so that's the default. It's a rest, it's a silence, if you will. Okay, so now we've got this information. We're going to come down here and we're going to look at the duration of the note. If the integer of note, if the third position of note, so 0, 1, 2, so this is less than or equal to 0, then we're going to default to 100 because it doesn't like to handle stuff that's too short. The wind sound likes to blow up if you try to feed it stuff that's too small, so we're going to set a duration, minimum duration of 100 milliseconds. Otherwise, the duration equals the integer of the third position times 100, so in this case over here it would be 2 times 100, 200 milliseconds. And then we're going to feed it to wind sound. We're going to feed it the frequency and duration that we've come up with up here, and it will play. So that's it. Okay, let's make it work and see what happens. Okay, we'll copy this one. Control C, Control V, and then we'll push enter. And of course that was Ode to Joy. Yeah, so that's it. This is our more complex version. I have some more room for improvement, and I'll be working on that. Well, I hope you found it useful and interesting in your Python programming and perhaps in your music interests.